Adam, I like these interviews. These interviews are like essential to Science Nights.
Yeah, and they're fun.
Yeah, and
definitely.
we always end up meeting someone cool or learning something new.
Absolutely.
The worst part of it, I bet you can guess.
Waiting around for the call.
Yeah, that's the thing. Like, we get all this stuff set up, and then it's just, man, I wish they'd call. Listen to that familiar Skype. That familiar Skype sound. That's the one.
Yeah.
Steven.
Hey guys.
Hey. Steven.
How you guys doing?
Good, man. How are you? Are you above water?
We are. We
Yeah?
got really lucky with that.
Yeah. Harvey just passed you right over.
It did. So I'm sorry it took me a little while to call in. It, the time difference and all that.
Yeah.
Sure. You sound a little.
Yeah,
you sound a
you
little
all right?
throaty. Are you okay?
Yeah. So I've just been talking. Do you mind if I grab a little drink of water real quick?
Yeah.
No, go ahead, man.
I'll be right back.
I can't believe.
Hey,
Whoa, who are you?
Wait a second.
Oh, hey.
Steven!
Hey, how are you doing? I didn't tell you I'm in Seattle. Did I tell you I'm in Seattle?
Oh God!
Wow.
Surprise!
Well, I'm glad you're here.
Hey, do you mind we could sit him here and?
Yeah,
then
sure,
we
no
can-
problem.
Cool. So give us a second. We'll
All right,
get
yeah.
this going.
We'll be right back with you.
You've elected to come along with us on another episode of Science Nights. Hello, everybody. I'm Josh,
I'm Adam.
and wonder beyond wonders, we have an actual celebrity VIP super person in studio with us. Hello, Steven.
Oh wait, you meant me?
Yeah, that was you. Yeah.
Oh, that's cool. I was looking. I was excited. I thought somebody was coming in.
Elon Musk, what? I
Why
mean,
did you
what?
say that?
Seriously, sir, we can't thank you enough for joining us in studio today.
It's a real privilege and an honor to be here.
So, what the H are you doing in Renton? Why are you in our neck of the woods?
I am here for RenCon.
Woo!
Woo!
So, if you're viewing this as it came out, RenCon was about 3 weeks ago.
Yes. So we've traveled in time.
A little bit. There's a lot of time travel in the studio.
Yeah.
It happens.
This is the studio of the imagination.
So yes, so I'm here again. This is where I got to meet you guys last year, and so I've done a panel already. I'm doing another one this afternoon.
That first panel was with you guys in Blue Origin. Was you in Blue Origin? That was fascinating.
Yeah, that was really cool. I'd not met them before. So NASA partners with SpaceX and Boeing on a day-to-day basis, but Blue Origins are kind of the new kids on the block, and I think that we'll be doing more stuff with them. I can imagine. Partnering with them for some cargo crew kind of stuff that we do already, but they're a little more focused right now on the woohoo, like we're gonna take people to low Earth orbit and just kind of do the touristy thing. So it's a little different.
They
focus.
want to essentially develop a shuttle program similar to the shuttles from the Enterprise.
Yes.
They want a reusable up and down shuttle,
Nice.
which
That's
is
interesting.
awesome.
Yeah.
And it's local. They're the people that were at his presentation are based in Kent.
Kent. Yeah.
Very nice.
Yeah.
Awesome.
Which my wife was really excited about because we'd been having this whole discussion recently. So Houston is awesome. Mm-hmm. Like being there.
It's underwater right now.
Most of it. Fourth biggest city in the country. And I've got some stats on that actually, because I keep things in my head that just don't matter.
Sure.
But I'm not sure that it actually is the surface of the sun, but I think we're in the same zip code.
Okay.
It is so hot there. So my wife and I got here, and she has been bugging me the entire time. Like,
Hey, Steven.
she's saying, like, oh, that's a cute. We could just live here. That's a nice cardboard box. I'd live in it. I don't want to leave. But I was like, but there's no NASA here, and for me. Working for NASA is like getting to be on the TARDIS. Like I'm hanging out with the Doctor, seeing the wonders of the universe and beyond, and to come off of that and do something else would be like having to leave
leaving
the
the
TARDIS.
Doctor.
It's like it's one of those things. But now she's like, so Blue Origins is here. That's sort of spacey.
And you're like, oh God, why?
Man, really?
So, most recently, we just did an overview episode on physics.
Ah, yes.
And over the course of our correspondence together over the show, you had mentioned several times, and I think it was finally in that physics episode that I brought it up, the interconnectivity of all of the disciplines of science.
So true.
Yeah.
So, not only do I want to pick your brain and find out what's fun with Steven this week, why don't you give us a little bit of your spiel on that?
Sure. So I'm a systems biologist. So when I look at things, I look at how everything connects to everything else, right? and all of the universe is just a system built upon a system built upon a system. And science isn't a tangible thing off by itself. Science is this verb that we use to explain our trying to understand the universe. And even that has a hierarchy of sources. And so the whole STEM thing, science, technology, engineering, mathematics, all of those things work together. So science is our big idea, way we're understanding the universe, and math is the language we use to express that.
Sure.
Right? But even in the sciences, you have this sort of hierarchy. So physics is sort of the mother science.
Right.
So physics is our trying to understand matter and energy in the universe.
As
So
it interacts with the rest of the universe.
that's exactly right. So it's this sort of foundational understanding of all things. Now, if you look specifically at how molecules interact with each other, now you've got chemistry.
Yeah, absolutely. Elements connecting and making different compounds.
Exactly
and stuff.
right. Which
And
is still,
NaCl.
which is still physics,
Oh, sure.
right?
Yeah.
But it's just a specific kind of physics. Now, if I'm looking at a specific way that chemical compounds go together in such a way that they create things like metabolism, now we're talking biology.
DNA and
Which
cells.
That's
and
exactly right. Which is all really just chemistry, which is all really just physics.
physics.
Right?
Okay, I'm
And
following you.
You can just keep going with that.
Sure.
Right? And so each one sort of keeps coming back to this, because I can't understand how photosynthesis works if I don't understand how chemicals go together and
Sure.
how they give electrons and lose electrons
And how chlorophyll works into that.
that's exactly
yeah.
right. So I have to understand physics to understand chemistry. I have to understand chemistry to understand biology, which means I have to understand, right?
Sure.
So it all just marries together. Now, what happens, unfortunately, in academia is the people in these big colleges, they get these ideas and they have their sort of, this is my world, this is my bailiwick.
We've segmented it.
Bam,
out.
there
Right.
it is. And even within the individual sciences, so like psychology, you have cognitive psychologists, which are all about how you think. Then you have neuropsychologists, which is me, which are all about the wet works, like how the brain
Neurotransmitters
right?
and
And then you have
synapses.
behavioral psychologists, which are only concerned with how you act, right? But when you really look at it, if you're really honest with yourself and you're not just trying to protect your
Niche.
latest publication,
Sure, yeah.
or sell the book that you just wrote, all of those things go together, because we behave the way we do because of how we think, and we think the way we do because of the way the chemicals work in our brain.
Absolutely. Yeah.
So it all ties in together. So I'm a global thinker, which makes me unpopular amongst the academics.
But it's another way to look at it is maybe a sociology analogy. We're all Americans in this room. We're all Americans, but on Earth we're all Earthlings.
That's it.
You're still the same thing.
Yes.
You're just interconnected.
Yeah. So even in a smaller microcosm in the military.
Sure. There
right?
you go. That's a good
right.
one.
So if I'm in the Navy and some Army guys come in, we're gonna like mouth off. We're gonna
Sure.
whatever. But now if
you
some
boat rats.
exactly right.
Yeah,
But if some civilian comes in and mouths off to the Army guy, I'm right next to him. Like,
Yeah,
what the
you
heck are you
got his
talking
back,
about, right?
right? Yeah.
And then within the Navy, so I was an aviation guy, and we make fun of the boat guys.
Of course, yeah.
And then everybody makes fun of the submariners.
Yeah. And then there's the Marines, and you're just like, you do you.
You do you. We'll be over here.
We'll
Just
give you a lift.
just don't put that in your mouth, because
Yeah.
they God bless them, those Marines.
Some of the most bravest soldiers ever. Y'all are crazy.
You're a little crazy. And I say that as the uncle of twins, both Marine Corps sergeants.
Sure, yeah.
Yeah.
I'm not saying there's no merits there.
Oh no,
just-
they're not right in the head.
Yeah. Awesome.
But I really admire. I have a lot of Marine Corps friends, and Semper Fi. We're all here together.
Absolutely, yeah. So back to the physics thing. Is there a part of physics, a segment of physics that you like the most? Like for me, the laws of motion are probably the most interesting part of physics for me.
Absolutely.
And we experienced inertia on the way over here,
We did.
which was amazing.
Yes.
Because everybody has a car or travels by bus or any kind of mass transit or any transit in particular. You experience inertia all the time.
Right. Or getting up from the couch.
Sure. The flow of your blood.
Exactly. I mean, it happens. So for me, it's finding that marriage, in looking for the theory of everything. So you have the Newtonian and
Einsteinian?
physics,
Einsteinian.
which is the well, we are in Seattle. So
I was drinking. I really appreciate it if you didn't
I was looking
do
for a
that.
spit take, man.
Yeah. Not on these mics.
So but that's like the physics of the big, right? It's how we get our Cassini to Saturn, know where it's going to be, know how to bumper pull it off for the gravity assist and all that kind of stuff. That's Newton, that's Einstein, that's the big stuff.
4 gravity assists over the course of years.
Oh,
It's ridiculous.
Voyager is like 12. Like
Yeah.
it's crazy.
Yeah. No
So-
bigs.
So but think about that. So think about when it left here, it took 7 years to get to Saturn.
Mm-hmm.
So what that means is we had to do those gravity assists not based on where Saturn was at the time,
Where it's going to be.
in 7 years.
Yep.
Right?
So, speaking of these year-long trips or like massive length of time, Pluto was discovered in 1930.
Yes.
In 2006, it was declassified from a full planet status. In that time, it never revolved around the sun.
Correct.
That's mind-blowing to me.
Correct.
You weren't even a part of our solar system for one of your years.
I think it's
247.
Yeah. So I said about 250. It's incredible. So the time scales that we're talking about are ridiculous. And then you have quantum physics, which is the other side of the coin.
The very little.
Which is the very little.
And weird.
And weird.
Yeah.
Because things don't act the way that things that we can observe easily do. Things happen. So you have these, you can have an electron in 2 places at the same time. And the electron sometimes is there, sometimes it's not. And where does it go, and how does it, but we're looking for that. There's got to be some connection. There's got to be something that bridges that gap, that helps us understand how those little things work to create the big things that we see. Because it's what we're made of. And that's where my fascination lies, is because for me, it's all about the system. And how do I marry this system with that system? And so that's my fascination right now, is how do I put those two together?
Right on. If you were to demonstrably, what are the best ways to demonstrate physics what are the best ways to demonstrate physics in the classroom, do you think?
So
other than dropping stuff.
For me, I like to do open-ended engineering challenges. So the way
I think you talked about this when we
I
first.
think so.
Yeah.
So the one that I keep coming back to is the way that I taught Newtonian physics, inertia, that
laws of motion.
Yes.
Stuff like that.
So, but instead of saying like, here they are, memorize this, whatever, we built we built roller coasters.
Yeah.
And the kids discovered the laws on their own.
Nice.
And then I named them. And think about what that does. So the thing that I focus on is making science relevant, right? And not just awesome, but relevant to you as an individual. So think about what that does for a kid to discover in the same way the law of motion and physics that Sir Isaac Newton himself did. And I can tell that kid, I'm putting this name to it, but you discovered this. You figured this out in the same way.
Because then it's more hands-on, so they're more interested in it. It's not just something that you told them, so they're repeating on a test. And,
And are you ever going to forget that?
Right, exactly.
When you have that moment where you did this.
My 8th grade science teacher, Mr. Canfield, showed me what a calorie is we burnt a Cheeto.
Yes.
And it went, and then we burnt a piece of broccoli, and it was like a slow burn. And he's like, Cheeto has a lot of calories in it, so it just goes. But the broccoli may have the same amount of calories or less, along with the other compositions in it that keep it from burning. But the chemical reaction of burning calories is what we use as humans for energy.
Right.
I'll never forget that lesson because it was demonstrated.
There it was. Yeah, exactly right. So that's the kind of so I like to present a problem. Here's your materials, here's the constraints. Go. And just let the kids figure it out.
Sure.
And one of the things that's hardest for us as adults and for teachers and for parents in particular is to let your kids fail. Let them try something and have it not work. And then have to look at it and figure out, what was it that went wrong and how do I redo that? We don't do that anymore.
Right.
So.
Yeah, because failures looked at failure. Failures looked at as
in a negative.
In the negative,
Absolutely.
Yeah. But in science,
it's
you
one
want
of the most
failure.
important things we're doing. If you're not working to the point that you're failing,
you're not
doing
enough.
anything.
You're also not learning anything.
No, you're just doing demonstrations.
You're just reaffirming what we've already known.
Yes.
Yeah.
Like if you want to see how a vacuum works, well, you can demonstrate that easily with a a bottle and a match.
Absolutely.
But if you're not pushing that boundary and
Right.
failing to do that in other ways, then
Yeah.
you're not really...
Well, I met this kid today, CJ, which, by the way, CJ, if
Little
you're out
kid,
there,
yeah.
dude, you're a rock star.
He was Pikachu outfit, costume, was like, I want to be a science man. And we're like, yes, you
Yes,
do.
he does.
Nice.
And that kid was on it, man.
I heard him talking about trees and
Yes.
stuff.
So he's at that point where he's gathering knowledge, right?
Yeah.
So he's watching these documentaries, he's learning things, and his head is full of these facts and figures, which is fantastic. So when I pulled him aside, I said, CJ, your job, brother, is to not just learn the things that we already know. I want you to push it that next step. I want you to create new knowledge, right? Create new technology, create a new answer to the question, create a new question that we never thought to ask
Right.
before, right?
Sure,
So
yeah.
it's not just about memorizing all that stuff. That's awesome, but that's just the foundation. That's just the
Yeah.
starting point. So your job, and this is, a 10-year-old kid, I'm like, your job is to teach us the new stuff. And
Yeah. I want you to teach me
and
something.
of course, CJ is just like, okay. So I gave him I gave him one of my pens. I have pens on my thing here.
Yeah.
Oh, I gotta make sure I turn that around. You don't see that. I'm gonna push this. Anyway, so if that happened to turn around, we need to blur that out.
I can. That's fine.
So anyway, so NASA bosses, I remembered to put that off there. Anyway, but I gave him one of my pens, and I was just like, all right, when you become my boss, I want you to remember how nice I was to you today.
You're gonna find you in like the dusty annals of the underground
That'll be
NASA
it.
record system. He's gonna be like, "Is your name Steven?" "Yes, my boy, it is
yeah.
Steven. You were at a small theater in Renton one day, and I just want to say, here's your pin back, and you're not getting a raise."
That'll be my luck. That'll be my luck, and then I'll kick my walker over.
Yeah, exactly. So one of the hallmarks of recent pop culture, I think, that uses science for good and ill, is Rick and Morty. Have you
Yes.
been keeping up with Rick and Morty at all?
All right, so my daughter
Uh-huh.
and her fiance Ryan are huge, like quote every whatever,
Oh, we can do that too. Yeah.
and have begged me
Yeah.
for years, like, you gotta watch this, you gotta watch. So I watched like 2 episodes, and I couldn't quite get into it. but I've been told by my daughter, who really is the boss.
That's how kids do.
It is like, Dad, you got to watch this. So I haven't had a chance to. I've been a little busy. I've had a couple hurricanes. I've had some things.
Yeah.
But yeah, so I haven't had a chance to really sit down but I have to muscle through and just watch it. So
Well, the reason I brought it up is because, so science nights, we're trying to be science communicators and get it out there to the general public. Rick and Morty is very, very hyper fantasized, like, look at the possibilities of a multiverse, the importance of continually pushing the boundaries of invention and engineering and physics and stuff. And I'm wondering, like, there's a lot of negativity that comes out of viewing that, as far as how violent it is, how vulgar it is and
Right.
stuff, but it does push the mind in the right way in certain areas. So I'm wondering, like, if you had seen it, I was wanting to take your take on
so
that.
I really like the pushing of the envelope. I like the fantasy that they do. I like the way they solve the problems they create for themselves. I really do like that part. Why they have to vomit so much when they do it? That's where
beyond you a little
That's
bit.
where you lose me a little bit.
Sure.
I'm like, okay, I understand potty humor as much as the next guy who used to be a boy at some. You know what I'm saying? Like,
Yeah.
I get that. I thought Captain Underpants was hilarious, but it seemed I was like, oh, okay, well, you vomited for no
Gross.
apparent reason. Okay.
Yeah.
It's not for everyone. As big of a fan as I am, I
Yeah.
do know a few people that just couldn't get
Yeah.
into it either.
Right.
So,
Mike?
Yeah.
Yeah, exactly.
Yes, exactly. Yeah.
So, but again, like you said, and I see the real value in that. I see the value in storytellers who are pushing the envelope and doing things. I just finished Neil Stephenson's book, The Seven Eves, which was incredible. It was incredible. So
Never heard of it.
So The Seven Eves is this. It's the premise is there was an agent that hit the moon, and it hit it so hard that it broke it into 7 pieces.
Okay.
7 large pieces, and then of course several tiny bolides and whatever. And eventually, those bolides rain down upon the Earth and basically destroy the planet for 5,000 years. It makes it uninhabitable.
Gotcha.
So human beings have to go into this cloud ark, and there's this whole like whatever. But Neil Stephenson writes tomes. I mean, we're talking thousands of pages long.
Sure, like George R. R. Martin style.
Yeah. Oh my. Oh, if you put all of George R. R. Martin's books
Into one
together,
book? Yeah.
that's one of his books.
All right.
So
all right.
he wrote,
Wow.
it's ones that people may be familiar with. So Cryptonomicon is his most famous book.
Okay, yeah, people have definitely heard of that.
Yes.
Okay.
And then Anathema is another one. So he's written, but this book was so well done. He had a whole chapter talking about delta V, which is the change in velocity that you have to do if you're going to move up in orbit or back in orbit, and how you move in space.
We've talked about that a little bit on Waiting for Players when we played Kerbal Space Program.
Yes. So
Yeah,
Kerbal,
okay, yes.
Kerbal does a great job of that. So he devoted
Love
like a
that
whole
game.
chapter to talk about how that really works, and it was on. It was
But
spot on.
is it a narrative that he does? So he does that whole chapter in a narrative style?
He does.
That's awesome.
Yeah, so
that's,
they become-
that's a writer to aspire to be.
It is, but they become asides that are important to this next step, sort of thing, right?
Yeah.
But he did it so well that like I caught myself when I was outside just checking, like, okay, it's still there. it was just compelling, and it's storytellers like that, and like Andy Weir and the Martian, and,
yeah.
these sort of things. It's fantastic. And we can have some fun arguments about like the exact science and how it maybe was a little off here or there for the story, but the end result is it gets people excited and gets
Yeah.
them thinking about that sort of stuff, and it creates a position where they can put themselves in that position, which is what we're trying to do at NASA, which is actually engage people in the mission that we're doing, not just tell you about it. We want you to become a part of it.
Right.
That's what was so. We talked about this, after or before your panel, but that was what's so encouraging about the total eclipse was you had people from like, for instance, I was at a manufacturing job, and there are office people, sales, purchasing, the president of the company, the vice president of the company, and then there's us in the manufacturing part, shipping, receiving, machine shop stuff. All the guys lined up outside watching the solar eclipse.
Right.
And that's something that should be experienced across, like it was across
Yes.
all forms of all walks of life.
Absolutely.
And I'm glad that I was actually able to witness that. And if you go to the Science Nights Facebook page, you can see some pictures of that. That was pretty cool.
That was incredible.
Yeah.
It was incredible. I got to experience it with 1,200 teachers.
Oh
That
man,
was awesome. That was only 68% though.
yeah, that's too bad. He was at Totality.
We drove down to Eastern Oregon to
Oh, yeah.
witness Totality. It was everybody that I've talked to that was either there with me or that saw it, Totality also considers it life-changing.
It is.
It was
Really
amazing.
genuinely is. And for me, it's so it's sort of like I was talking to my wife as we were driving into Renton from downtown, and you can see Rainier, right?
Yeah.
And it's twilight, right? So you're getting into the sunset, and the sun is shining just on this one side,
just
of
this one
Rainier.
facet of Rainier, yeah.
And it's this tangible moment, like, hey, wait a minute, like that's a real thing. That's
Yeah.
not just a picture of the thing.
Yeah, it's not a matte painting.
That's a real thing. And it's the same thing with that eclipse. Even only seeing it 68%, but seeing the moon come in front of this, it's this reminder that these are
Right.
real, tangible things, and we're in this universe.
Yeah.
Right? It's not just us, that these are real things that exist. And so it's that reminder, that moment of our place and where we are. It's a moment of wonder, a la Carl Sagan,
Yeah.
or any of those.
Yeah, the
those
pale blue
great
dot kind of
communicators.
way.
Absolutely.
Thinking it. There was a recent image from Cassini that we featured on our Cassini episode. It's Saturn backlit from the sun, and you can see Earth like way. It's this big. It's this big,
Right.
way in the distance. I'm like, that's the pale blue dot image in high def. Like that's exactly what
right.
Carl Sagan was.
Did you
talking
get to
about.
see the video
Of
from Huygens?
No,
So we just released.
it is Huygens.
If you go,
Yeah, that's what we were. That's
I
what
know.
we said.
I know. I'm
We
just-
figured that out before the show.
so if you go to www.nasa.gov,
sure.
Somewhere. Yeah, probably.
Oh, sorry. Yeah.
Probably right there. I was pointing the wrong way. It's this way.
Yeah.
and if you go in there and look at the Cassini mission, look at Huygens, we've posted a video of Huygens from like coming in from the high orbit into Titan.
Okay.
Every moment till it lands.
Nice.
And then
Yeah,
it
nice.
looks back up and you can see the sun and it zooms in on the sun from
It's awesome.
mind blowing.
Yeah.
It's
Yeah.
mind
That's
blowing.
amazing.
So we're taking up a lot of your time, but I want to hit another thing, and you've already brought it up, having to deal with hurricanes. I want to talk about Harvey because you had firsthand experience with
Yes.
Hurricane Harvey
And Irma.
and Irma. So
that's a
can
thing.
you walk us through I don't know if you have to start from start to finish, but can you walk us through Harvey?
Sure. Yeah, let's do it. Let's do a physics
Sure.
Right. So,
Nice.
so it's all energy and matter, right?
Mm-hmm.
So let's think about it as an energy and matter problem. So we have energy coming in from the sun. That's a good thing.
Yeah.
We have a greenhouse effect that keeps some of that heat here so that the planet remains habitable. That's a good thing.
And water in the ocean, as well as algae on the
Yes.
ocean surface, trap some of that heat too.
Absolutely. So the water, and one of the reasons it's so important to life is water is this amazing compound that does things that nothing else does.
Yes.
It absorbs energy
Mm-hmm.
and it holds it, right? And it's really slow to change, relatively speaking.
Right.
So
Especially when you have like mass ocean quantities.
absolutely,
Of it.
Yeah.
absolutely. So the Gulf is a rather isolated, comparatively, area.
Sure, by Mexico and kind of bounded around by Florida too. A
Yes,
little bit.
and it's
yeah.
very
Yeah.
near the equator,
Yeah, so it's warm.
which gets direct sunlight, and you have a thickening atmosphere that holds even more and more of that temperature, which then bounces off the atmosphere and back into the water to heat it even more. So now you've got energy.
a lot of it.
A lot of energy. So then as this storm forms, the energy of the heat in the water fuels the movement of the water above it, which is the hurricane.
Mm-hmm. And then the wind and stuff starts to
Yes.
coalesce.
And then you have the Coriolis effect,
Yeah.
which makes it move in a particular direction.
The spinning of the earth makes it turn.
It does.
Yeah.
So
Which is wild to think about on its own.
which again reminds you that we're on a thing, right?
Yep.
We're
Right.
on this thing that's moving at 1,000 miles an hour.
Yeah.
That's just crazy. So you have all this energy input, and then Harvey becomes this superstorm.
Yeah.
Yeah. And then it moves into us, and it stops.
Just kind of hangs there.
Yeah.
So
yes.
it's
Yeah.
picking up water from the Gulf that is moved up into the atmosphere because of the energy of the heat that's there. And as it moves, as it goes around in this direction on the eastern side, it drops the water. So by the time you're on the western side, it's relatively dry, but then it goes back over the Gulf,
Reacquaints or
And it fills up
reacquires.
again.
Yeah.
so it sat in one spot, and then it moved out just a little bit, just enough to get warmed up again,
Yeah.
scooted over just a hair, and moved back in.
Yeah.
And
wait, I
dumped
wasn't
more
done.
Water, and dumped more
Pretty
water.
much.
Now, just to give you an idea of how much water we're talking about, we measured it. We're talking about 9 trillion with a T, 9 trillion gallons of water. So a trillion is a million
Billions.
billion,
Yeah.
right? 9 trillion gallons. A gallon of water weighs 8 pounds.
Okay.
So that's 72 trillion pounds of water dumped in one place
So you
over the course of 2 days. Hold on.
Okay.
Hold on. To give you an idea of how much weight that is, that water shifted the crust of the earth 2 centimeters
Wow.
down.
That's amazing.
So
wow.
did Houston lose altitude or whatever? Like
2 centimeters.
oh my God, it's that much lower.
2 centimeters.
Like
That's
we're talking
amazing.
about sea level, right? Because like
Yes.
here we're about.
Oh, dude, we're right on sea level.
Yeah.
Yes.
Yeah.
Yeah,
Here we're like
yeah.
3,000
Yeah.
feet above, I think.
Yeah.
Like
Right here? No, we're a lot less than that
oh,
here. Yeah.
okay. Snoqualmie's like 3,000 feet.
Yes. Yeah, you're a couple hundred feet. Yeah.
Yes.
Yeah.
Yes.
But still. And what happens is, and you have places that are designed in the environment, right? You have these bayous and stuff, and their job is to catch the water and filter it. But when you have 9
Yeah.
trillion gallons, it just has nowhere to go.
Yep. And you can see the images of how it had nowhere to go.
That's exactly
Wow.
right. So I got incredibly lucky. So we were just high enough, and I mean like just high enough, because I live right on the bay.
Yeah.
So for us, it was the storm surge. So as that wind is pushing, it's literally pushing a wall of water in front of it.
Sure.
And the storm surge in Galveston and those areas was, 10, 12 feet.
Yeah.
Yeah.
Right? So the bay came within 100 yards. And I mean, I just watched it creeping.
I remember seeing the pictures. You're like, that's where I jog.
That's it. Right there. You see that little black dot out there?
Yeah.
That's a trash can, and it's bolted to the thing that it's sitting on. That's now 4 feet underwater. Yeah, it was crazy. And I sat on the outside and did a Facebook Live, like to show you the wind and stuff like that.
Yeah.
But one block over, my friend was chest deep
Wow.
in their living room
Wow.
in water.
That's crazy.
And when I try to describe to people, like when we went in to clean out their house, we had to take the floors to the concrete slab.
Yes.
Which is beneath the hardwood, which is beneath the carpet,
Yes.
which is beneath the padding.
Yes.
Yeah.
And then all the walls, when I say all the walls came out, I mean there's studs. There's no insulation.
Right.
There's no,
Yeah.
because everything was soaked.
Yeah.
And then imagine all their pictures of their kids and like,
Yeah.
I mean, just all gone. Just all gone. But my beautiful wife, who I have to mention, because she's here, and I don't like sleeping on the couch. She actually offered, because she's a photographer, and people, the thing that struck me about this storm, and I think that made it very different than what our
Humanity.
experience in Katrina was, the traffic issues were people coming in to help.
Yeah.
Right?
Right.
People with
Nice.
boats. People with their fishing boats. You know, we had the Cajun Navy came. It was incredible.
Mexico came in to help.
They tried to.
Yeah, I wish. God.
I'm in the wrong capacity at the moment to talk about why.
I'm not.
Yeah.
45, leave him alone.
So, la la la. So
Yeah,
anyway, but my wife, even so, she's a photographer, and she was just struggling with what can I do to help. And she's figured out, like, when people have lost these photographs that have been, they're mangled or whatever, she can actually go in and Photoshop them and fix them
And restore
like,
'em.
restore them. And so
Nice.
she's going to do that for
That's
people.
awesome.
That's
in the area.
amazing.
Yeah,
Yeah.
yeah.
You will change people's lives that way.
Can you imagine?
Yeah.
I mean, it's just
That's
Absolutely.
awesome.
So anything that
Definitely.
people can, like I said, these fisher guys, like they just have these flat bottom boats that they go out and drink beer and catch fish. They brought them, and they were pulling people out of there. It was
Yep.
incredible. It was
Yeah.
an incredible experience.
I want to equate this a little bit to the argument that climate change isn't real. So that energy that you were talking about, seeding the storm of
Yes.
Harvey and subsequently seeding Irma.
And Jose and Katya all at the same time.
So-
that's a whole other
Strengthening them.
conversation.
Yeah,
Yes.
there may have been storms that were powerful in the past.
Yes.
But not to this dynamic.
Right.
Not to this level. And on another note, if you think that, that's just a problem down south, I'd like to point out that most of the northern United States from
That
South
we're on
Dakota,
fire right now.
Yeah, from South Dakota on west,
fire.
we're on fire. Seattle is experiencing a drought.
That's
and
not a thing.
we
How is
don't-
that a thing?
We don't do that.
Yeah.
By the time this episode released, we'll be into October, and I hope that there has been a substantial rain recently.
Next week is supposed to.
I
But
freaking
next week is
hope
supposed
so,
to.
man.
I offered to set up a thing in Houston and do a bucket brigade.
And bring some over here.
Because we have
Yeah, we
9
could have used
extra
it.
gallons of water. That if we could just get the line going, I think we could get it up here.
Just be sure to stop by Montana on the way,
Just,
because
you know,
they
a
could-
little bit, just
they,
a little
like,
bit.
As
Throw
much
out a
as
couple buckets there.
yeah, as much as we need rain here, it's worse
Yeah.
to the middle of the United States, from from Canada down through Montana, South Dakota, and North Dakota. It is ablaze.
It is. Well, and so the issues with climate change aren't just, it's not just stronger storms. It's not just, it's a shift, right?
Right.
It's a shift in where things are happening and they shouldn't happen and they do happen. So you have desertification. You have like all these sort of things because it's the system is off, right? It's like your
Right.
car, right? That one
Right.
thing goes a little wrong and you're just
It's
off.
like a domino effect, though.
Or people's bodies. Like you don't get the rest and all of a sudden you're catching the flu and you're catching the whatever, but it's all tied together.
Yeah.
Because it's the system. The system is breaking down and it's our fault.
And it's staggering that there are still climate change deniers when they're like, this is just extreme weather. And yes, that's true, but it's extreme weather that wouldn't have been here 40 years ago.
Right.
It's extreme weather that wouldn't even be thought of a century ago.
Right. Well, and if you're saying that same thing decades later, because we've been talking about this isn't new.
Oh yeah.
Right. Since
Carl Sagan in Pale Blue Dot brought up the dangers
He
of
did.
CFCs, and that's in the 80s was when they were discontinued.
Absolutely.
But that still affected everything.
It did. So we've been looking at climate change since the 50s and 60s. And for that whole time you have people going, no, it's just rough weather. Holy crap. That's 50 years worth of crap weather. At some point,
Someone's got to say something, yeah. Well, I don't want it to all be gloom and doom. Is there anything cool sciencey coming up over the next how about this? What's
So
NASA
much.
doing
Yeah.
at the beginning of 2018, say?
so we're looking forward EM1, which is an unmanned test of the Orion spacecraft. It's going to go out to the moon and around there and come back.
Very nice.
We're looking like late 18, early 19.
It's going to be so. This rocket is about the size of Saturn V, but it's like 4 times the power.
So strong.
It's so cool too.
Yeah.
It's like orange and white combination. It
Absolutely.
just looks really good.
It does. And so the difference, like the space shuttle, took 40 different missions to get just the American parts of the ISS up there. The SLS, which stands for Space Launch System.
Yeah, I got you.
The SLS, or the Space Launch System, which is going to put the Orion in where it needs to be, could do twice the volume of the space station in one shot.
So he's saying like 2 space stations could go up, whereas
one
it took
time.
40 to do one.
To do our
just
part.
our
Nice.
part.
Just
Yeah.
our part.
Wow.
So that's how much stronger, and we need that because so we're sort of turning over the taxi service to the ISS in low Earth orbit to companies like SpaceX and Boeing, and we're looking out. We're going to get out of here. Like we're pushing out into the universe. So that's the sort of thing that we're looking at now, which is incredible. So again, we've got some real dates and some people in line. They're going to do these things. They're going to go out and see these things again. And then along those lines, we're celebrating, coming up in October at Johnson Space Center, we're celebrating the 50th anniversary of the Apollo missions. And the Apollo 11 capsule is going to be at Johnson Space Center.
We need to get a hold of you
Yes.
during that time, because I think after we finish geology,
We do have an Apollo series coming up.
We're moving up on Apollo.
So in October, which when you're talking to us now, that's going to be then, because we will have both 11, which was the first mission, and 17, which was the last one.
Oh man,
Nice.
Which is the last
awesome.
one. And then we also have the Saturn V that was supposed to be 18, is there.
Okay.
And so I can definitely remote
Nice.
from there, and I may be able to talk to my very good friends at the Space Center Houston and see if we can get in there and do a remote and get those in there.
That would be awesome.
Very
We
nice.
would
That would
we
be
would love
amazing.
that. Also, I mean, I can't believe we neglected to see this. You were in the same facility when James Webb got the door shut on it.
I did, yeah. So I got to see it when it was at Goddard in Maryland. Which is where they're putting it together. And I got to meet John Mather, I should say Nobel laureate, Dr. John Mather. I got to meet him, and he's the principal investigator for that whole project.
Jeez.
And then right now, it's at Johnson Space Center. So I've gotten to see it twice. And it's in this room that recreates the conditions in space. And it's so big that you can put the whole thing in there.
Yeah, it's a massive vault.
It's huge. So to give you an idea how big it is, it takes 10 days to pull the air out of the room to create the vacuum. And then it takes 100 days to bring it down to temperature that what it would be in space. And
Wow.
and they're working with like double digits Kelvin.
Yeah.
Yeah. Nice.
So if you,
God,
had,
that's
if you had a
awesome.
little chart with Fahrenheit and Celsius
And Kelvin, sure.
that would be a cool thing to talk about.
Absolutely, yeah. I mean, well, we can mention that real quick. Fahrenheit is, from what I can take it, Fahrenheit is how we measure temperature as humans as far as comfort level goes.
Yes.
Celsius is how we measure it as like 0 to 100 for water, essentially. And then Kelvin is the absolute scientific way to measure temperature.
That's a kind of, I can see, yes, that's okay. I like that. So Fahrenheit was a crazy German guy.
Yeah.
That was actually his name. And he developed the system that we in America, and only in America, still use.
Yes.
So he set 0 at the temperature at which salt water freezes.
Okay.
And then 32 is where fresh water freezes, and 212 is where water boils.
Right.
Yeah.
Rather arbitrary points
Sure.
on the spectrum. Celsius is a little more logical.
A little precise.
It's a little more precise. So you have these, so they set 0 at where fresh water freezes, 100 at where water boils, and then they set equal increments between so that there was some logical reason for the difference.
Yeah.
So like a nice day is like 25 to 30 Celsius. That's
Yes.
like a nice comfortable
Absolutely.
day.
So then Kelvin used the same scale as Celsius.
Okay.
But instead of setting 0 at the temperature at which water freezes, he set 0 at a theoretical point at which all matter ceases to move.
Absolute zero. That's, if you ever heard that process, that's what
Absolute
absolute zero is. And as far as I know, we can come close.
Close.
We can't hit it.
And we haven't found it even in the universe. Like we've looked, we haven't found it, but we've gotten close. So James Webb, where it's operating, which is at a Lagrange point, it's L1, which puts it about 1 million miles away from us. It's going to be operating at about 20 degrees Kelvin.
That is intensely cold, people.
So
there's no negatives in Kelvin.
So like
zero's where it stops.
A nice day in Kelvin is like 275.
Sure.
Yeah. So that's.
I like my way of doing it better. It's like it's human because like your average human's 98.7. That's a little too warm outside.
A little too warm. A little too warm. You don't want to be inside somebody. That's
Sorry, pardon my ignorance, ladies and gentlemen. Stephen, it's been fantastic to have you here. I can't wait to correspond with you again. And who knows, maybe you and your lovely wife will join us out here in the near future if you ever get that
she
Blue
has
Origin
her way.
job.
Yeah, that's awesome. Thank you guys. I really enjoy hanging out with you.
Yeah, it was
Absolutely,
awesome.
man. So be sure to check out nasa.gov for all the things that Stephen was talking about. And we'll see you guys next week on Science Nights, where we will be discussing science. Science. Bye.
Bye.
Bye.